Okay, let's look at the exponential properties. I'm pretty sure you have seen these before, but it's always a good idea to refresh your memory. Alright, so first one, b to the x times b to the y. Alright, if you combine that together and write it as a single exponential function, this would be b to the, alright, so you have x b's here and y b's here combined together, so it's going to be x plus y b's. So it's going to be b to the x plus y. Alright, so if you're not convinced, let's look at a small example. Alright, so you can see that let's look at 7 to the 7 squared times 7 cubed. Right, 7 squared is the same thing as 7 times 7. Alright, 7 cubed is same as 7 times 7 times 7. Alright, how many 7s do we have? 1, 2, 3, 4, 5, so it's going to be 5. So 7 to the 5th power. Right, but where did that 5 come from? So that comes from, you have 2 7s from here, and you have 3 7s from there. Add them up, you get 5. So this is really 7 to the 2 plus 3. Right? That's why you will get b to the x plus y. Alright, number 2. Alright, so this one is a division. If you have b to the x divided by b to the y. Alright, so if you write it as a single exponential function, so this is going to be b to the x minus y. Alright, why is that? Right, so let's look at a small example. Right, 3 to the 5th power divided by 3 squared. Right, so what is 3 to the 5th power? Right, that's the same thing as 3 times 3 times 3 times 3 times 3. Right, so you have 5 3's on top, and on the bottom you have 2 3's. So you have a 3 times 3. Alright, but what we can do is to simplify by canceling common factors. So you have 3 here, cancel with 3 on the bottom, and you have another set of 3's, so you can cancel those. Alright, so therefore what's left is 1, 2, 3. So you have 3 3's left. So you have 3 cubed. Right, but where did that power 3 come from? You have originally 5, you cancel out 3, so it came from 5 minus 2. So it's going to be 3 to the 5 minus 2. Alright, that's why b to the x over b to the y is equal to b to the x minus y. Alright, so number 3. This one is b to the x, then you raise the whole exponential function to another power. Alright, so this is going to be equal to, alright, b to the x times y. Alright, right, this one looks exactly the same. This is a subtraction, so I'll make it a little bit longer. So this is subtraction, x minus y. This is x times y. Alright, why is that? Alright, so let's look at another small example. Let's do 5 squared, raise the whole thing to the 3rd power. Alright, so you have 5 squared is same thing as 5 times 5. And raising to the 3rd power is multiply those guys, 3 of those guys together. So you have 3 of these guys. So it's going to be 5 times 5. So that's the second one. Third one is 5 times 5 again. Right? So how many 5's do we have? Right? You have 1, 2, 3, 4, 5, 6. Right? Where did the 6 come from? Right? That is coming from. So you have 2 each, but you have 3 sets of that. 2 times 3. So that's why you have 5 to the 2 times 3. right? That's why b to the x raised to the y is b to the x times y, right? Number 4, if you have two different bases multiplied together, raise the whole thing to the x power, right? You can actually distribute this power to each base, base. So you have a to the x and times b to the x, right? Why is that true? Right, let's look at a small example. Right, so let's do a 2 times 5 raise it to the third power. Right, this means that you have 3 of 2 times 5. So it's going to be 2 times 5 times 2 times 5 times 2 times 5. Right, then you just collect all the 2's. How many 2's? 1, 2, 3. So it's going to be 2 cubed, right? How many 5's? 1, 2, 3. So 5 cubed, right? So you can kind of distribute, you can kind of think of, distributing power 3 to each base. So first base 2, and the second base is 5. So you have 2 cubed times 5 cubed. Right, that's why a times b raised the whole thing to the x is equivalent to a to the x times b to the x. All right, so number 5, a divided by b raised to the x is, again, we can distribute x to the top and bottom. So you have a to the x over b to the x. All right, so let's look at an example. So 5 over 2 raised to the third power is the same thing as 5 halves times 5 halves times 5 halves, right? But multiplication between fractions, we multiply numerators together and the denominators together. So you can see that you have 5 times 5 times 5 on top, so it's going to be 5 cubed on top, 2 times 2 times 2, so it's a 2 cubed on the bottom. All right, so again, this is kind of like a distributing power 3 to the numerator and also the denominator. All right, that's why a over b raised to the x is equivalent to a to the x over b to the x. All right, there are a couple other properties which is useful when it comes to solving equations involving exponential functions. So let's look at those properties. All right, so it says that if you have the same base, b to the x is equal to b to the y. So if the bases are the same and then the whole quantities are the same, then the power must be the same. All right, here's an example. If you have 7 to the x squared is equal to 7 to the 2x plus 3, right? Then what can you say using this property, right? So the quantities are the same on both sides, and they are exponential function of the same base, which means that the powers must be the same. So the exponent of the left-hand side is x squared, and the exponent of the right-hand side is 2x plus 3. So therefore, x squared must be the same as 2x plus 3, right? And the second example, you can solve for x if you want, but application of the first property. All right, second property. If x is not equal to 0, and also a to the x is equal to b to the x, right? This time, the powers are the same, right? And also the quantities are the same, right? If powers are the same and the quantities are the same, then we know that bases are the same. So a equals b, right? Here's a quick example, right? If you know that the 5 cubed is equal to quantity x plus 2 cubed, then you can see that the powers are matched. So therefore, bases, which is 5 on the left and the quantity x plus 2 on the right must be the same. All right, so by using these two properties to simplify the equations. All right, so those are useful when it comes to solving the equations involving exponential functions. All right, that's it. I hope that this was clear.